Hey, how's it going, guys? So here we are back again at the Python BACnet Stacks Playground. So I have a whole bunch of things to show you guys today. We're still working on the Vibe Code app 11, which is just seeing if AI can build a building automation system. It's using the Codex CLI. So basically, artificial intelligence is just given the instructions, a specification on what to build. It's going a lot slower than I anticipated, but and I think I need to kind of refactor it a little bit. So I'll talk a little bit about this, and then I'm kind of going into Vibe Code app 12, which will be how to scrape data from a building with a real sensor wired to a Raspberry Pi with a GPIO, and then sending that data via MQTT, where now I'm experimenting with the AWS IoT Core. So how to get data from a building, all custom Python scripts and BACnet onto AWS through MQTT Secure. Okay, so but first I'll spend a couple minutes where we are at here. So anyone that's a building automation technician, especially in new construction projects where people usually start out, the building always gets built the same time that the HVAC control system gets built, and then the mechanical contractor is building all the ductwork and installing all the fans and the pumps and plumbing and huge buildings, big commercial buildings, hospitals or whatever you name it. That's where I spent most of my career, is on new construction, large projects, where like the control systems, really big control systems, like for a hospital or some massive building, could be, if it was $1 million control system in US terms, it was a huge building. Just the control system was $1 million. So that would be a large campus, higher education building. So those are kind of the projects I worked on. Hundreds of millions of dollars of the building in general, but so all these projects were huge, and sometimes they would take many years to build the building. So let's say like a building takes a year to build. Okay, so this one's 18 months. So year and a half. This is just a generic Gantt chart I had ChatGPT generate. But they always start out over here where construction, concrete workers, they're roughing in the building, and then sometimes electricians are out there roughing in like a conduit under the concrete before it gets built. And then HVAC, the mechanical contractors out there in those early stages. Usually by this phase, the iron workers are done, and they're putting in the roof, and they're installing drywall on the inside. And then there'd be some kind of HVAC controls, wiring happening, the Division 23, which is just for HVAC control. Electrician would be out there running low voltage. And then basically at some point in the building, I would get to the buildings when there's usually a roof, there's usually windows, there'd be boatloads of drywall dust, and it's really loud, and a lot of people, very dirty environment still. There's no HVAC running yet. Like us as control technicians, we would turn on the HVAC, sometimes for the first time. Sometimes there'd also be startup technicians from specialized manufacturer if a project was sold with that. So basically, once you get into a project, maybe a year into the project, depending on the building size, we can light up all the electrical for the first time, get all the bugs out, and then we can start building the supervisory controller in the building automation system. So it's like the point I wanted to make is like these projects go very long, it can be months at a time, where the building is just sitting in this very slow phase of slowly getting devices online. If you're working with an electrician, maybe he's only half done, he or she, running a crew of specialized electricians for electrical installation, but everyone is eager to get all the devices online and the points mapped through. So what I'm trying to replicate in this AI builds the BAS through a specification is it's tailored towards these timelines in contracting. So all the contractors are really familiar with this. It's kind of, they live and breathe all these different projects going on, and sometimes there'd be different buildings in different states. So like this building's almost done, and then another building is only halfway done, and then this building hasn't even got the roof in yet. So like they're like the point is that the AI can go really slow over time, almost as fast as the building's getting built. And so I'm trying to kind of mimic that with this is what it's looking like with at the moment. So there's the AI has generated the entire app base already. It's huge. It's huge. So it's cranked out a full-blown BAS, but like it's too complicated, and some stuff doesn't work, and I'm forcing it to dumb itself down to like, I'm basically pretending that, hey, we're in phase 1 commissioning chat with only an electrician. So basically what's going on behind the scene is AI has built its own BACnet drivers. Just realized my little mouse highlighter isn't working. So AI has built its own BACnet drivers, and it's doing the same thing that a controls technician would be doing. When they come on site, the electrician wants to know, can you see all these devices? Or else I need to go fix the communication wiring, or I need to go fix a sensor. So like the idea is like this AI assisted application that's slowly building the building automation system is replicating what the controls technician does a little bit over time. That they could go on site and run a discovery, BACnet discovery, be like, and then tell the electrician is like, yes, these devices came online, but I still need 100 more. Go fix your issues in the communication trunk, and then I'll come back tomorrow and run it again. So what this is doing, it's kind of mimicking that startup building automation technician, just with validating that the electrician is doing their job, and like, yes, I can see all my devices. Then electrician needs to know, are all my sensors wired in correctly? And then sometimes the controls technician has to go around and actually validate that no wires are crossed, because that can happen all the time on really complicated systems. Is that the wrong zone temp sensor can get wired to the wrong device, and then as soon as you start programming the HVAC system, now the wrong sensing element is going to the wrong program, and things can get really muddy down the road. So like the idea is, if you have like a really good commissioning process of the control system, is that you do a really good point-to-point validation, and then after that is done, you go into functional testing modes where you validate the programming that the HVAC sequences are operating as correctly. So like what I'm trying to make here is that AI is like here's an electrician. So we're pretending now the electrician is chatting with AI during this startup phase, that me, the electrician, I need to just know that my devices are online, and then so AI is still making this code. We'll kind of go off of this work, is that AI will then have this table that like, here's all your sensors that they're online, and then the next phase of this project will be that the point-to-point will need to happen, and someone will need to be able to read and write, make points go on and off. So there's more phases to this. It'll come through later down the road. So it looks like it's still doing this. It's made still. So I'm just going to say what we want is please make sure the crone wake-ups only happen once every 2 hours. Let me know if you cannot adjust the crone wake ups yourself. Send. All right, so we'll just keep on checking this. It's basically a self-building automation system with web apps. Okay, so like what I wanted to go, maybe just briefly show you guys this, is that, so we'll get to Vibe Code App 12, the MQTT, in just a second. But so this is, actually, this is the app. This is the code that it's making. So it's made a ton of code already. So like it did all of its alarm resolving, all of the, I think I showed this before. It's like just making an enormous code base, all in Python, and then it'll have the ability to modify and completely maintain itself. Which I think is like what I wanted to do, obviously, is like it's going to maintain its own drivers, it's going to maintain its own UI, web app framework, and then the only thing that, at some point in time, we'll get authentication and everything like that. So it's already made all that, actually, which is kind of mind-boggling. So it pretty much builds a whole building automation system even before this pretend electrician is done. So what do we have here? So we have a bunch of, it's running a ton of code. I just wanted to show like it's built its own BACnet drivers already. So like based off of all of the code that we've done before, just in this BACnet Stacks playground, it's using all of our contexts from here. I might have to show you that later. I can't remember where it stuck it. Backend. So yeah, it's like at some point in time, like we'll just be basically validating that this app is working. So concept idea of the future, point being. Okay, so enough with this. This will probably be a long, drawn out process into the future. I might even write an article on LinkedIn about it. So I might just close out of this. Vibe Code App 11. Okay, so the next thing I want to play around with is Vibe Code App 12, which is okay. So just to recap, we're on the Linux Ubuntu server, the one that I've panned. I'll do that in a second, just to show you the server. And then what I ended up doing is I actually, before, like I was going to try and do something of showing the data on Python Anywhere, which is a web app framework, but I've actually was having some issues trying to use the test MQTT servers. So I actually just switched. This is something I wanted to do anyways down the road, is AWS has special features for IoT. So AWS IoT Core, I'll show you in a second, like I'm publishing data to AWS IoT, where then I think at some future point down the road, we'll try and get the data onto a Grafana table. But like at the moment, I can demonstrate that I can push fake sensor data to AWS IoT Core via MQTT. So like what it's doing, what I'm testing at the moment is it's running on here. So this is, I'm recording this video on here, and we're using, on the Windows machine, we're using Cursor AI IDE to massage files, everything that is needed. And then on here, Vibe Code App 12, there's some code. First of all, on AWS IoT, maybe I should have made a YouTube video on this alone, but how to set up that any device registered to basically here. This is AWS, and it has some features where you can, maybe I'll just get back in here. So AWS IoT, so curiously test, manage your IoT devices. And then what you can do is it lets you download a zip file, and then it lets you set up projects in Python, Java. Then there's another one too. It might have been C++ or something, but I chose the Python. So it lets you download a zip file once you set up your account. So I'm just going to zoom in on this. Extract all. So let's just see what it lets you download. Okay, so hopefully this isn't too hard to see, but it looks like I can't if you, zoom in very far. But how do I do like extra large? Okay, so this is basically it gives you a bash script, which is the Linux operating system scripting, bash and PowerShell for Windows, and then it gives you these. What these are is a .pem and a key, and then another .key and some kind of policy thing. So this is how you can securely communicate across the internet. MQTT. So MQTT secure. So we don't even need a VPN. We can just use MQTT secure. So this is what these .pem and key files are for. Is they're from the AWS IoT server. It's for encrypting data. It's the key and the pem. So basically it garbles our MQTT data when it's running across the internet. So then we can get it to AWS and then put it in a database someday. So my point is like when you set up your MQTT device as an MQTT thing, you just download this zip file, and it you can test and validate it. So and then so I'm just connecting one device. We could have many devices. So this is my so MQTT also works on a topic. So this when I did this before, it fired off a couple different. See if I can clear that. Okay, so like what I'm gonna do on my test bench is actually fire off to this topic SDK test Python some fake data. So that's going to come from here, from my little server. We're going to publish MQTT secure through the firewall. And then it's going to go out across the internet through AWS Core, and then we can see that through the browser here, which is pretty cool. Like, I know some other IoT companies, they might use a VPN to do all this, and they don't even need MQTT secure, because I think they're using a VPN tunnel. But I think it's kind of neat that you don't need a VPN tunnel. You can just do MQTT secure right across the internet with a .key and pem file. Okay, and then like the long-term goal is like we're going to use Ansible, which is an IT automation tool to push code to the Boss Pi, and then for it to publish live data read from a temperature sensor, and then we'll also be able to see it via BACnet locally, and then we'll be able to see this locally via BACnet, and then also on AWS IoT Core. And then someday I have to figure out how to get the data into a Grafana dashboard. Okay, so where are we going with this now? Let's check my Codex usage. Yeah, I had to add some more credits because totally drained my weekly limit. So that's running. This is Vibe app 11 of AI building the BAS. I'll talk about this in a second. So maybe I should just show you. Let's see, I'm just going to do a history in Linux, because I've been kind of jumping around a whole bunch this morning. Let's see, how did I do? There's also some kind of like a car event at my little town here, so if you notice a lot of engines roaring around out there, it's not me playing around with computers and IoT, it's some kind of a car event. Okay, so if I go like this, I just have to change directory into Python BACnet text playground, and then change directory into vibecode app 11. And then this should be our, oh no, this is, shoot, I have to go vibecode app 12. Okay, so I'm going to drill into this folder, which is actually here. Hopefully you guys can see this. Okay, I feel like if the text is zoomed in any further, it's almost hard for me to make out what's going on. So, okay, so this is vibecode app 12. And also another step I didn't show you before is I secure copy file protocol, SCP, the files from the Windows computer to the little Linux server. And then these are these key and encryption, key PEM, cybersecurity, encrypting files here. And then here's the bash file, and I validated that this worked. And then I want to do, just to show you this, I'm just going to run this Python publish fake temp. So that's this file. Let's just glance at, let's just run it real quick. Maybe I think there's a couple of arguments, so I'll just do 5. I think it's going to publish a few things at interval 2 seconds, sure. I wonder if I do that from here. Might be in the wrong directory. Which directory did I do this from in? Might have to cheat and ask. Can't remember what directory to run this in. Directory to run. I think like having AI like cursor or something like that is like super helpful even for IoT. So okay, so let's just do it from here. It's gonna tell us to go to this directory. Copy. Alright, so let's run it. Okay, so it's publishing data to an MQTT topic. And then, oop, there it goes. Probably did it already by the time I even got up here. So yep, if you see 1202 on here, 5 seconds a piece, or 2 seconds a piece. So just for fun, I'll clear that out and then I'll run it again. Publish fake temperature sensor data. Oh, there it goes. Look at them go. Alright, so we're basically validating that in this MQTT client test that you can get data onto the AWS cloud. And then I think like the next thing we'll have to do is create some kind of a script that would be in AWS Lambda on how to, another Python script that'll just be also listening to this and then dumping like, so at some point in time we'll need to create another Python script that listens to this topic and it sees these messages coming in and it'll dump this data into a database. I actually have never done that before, so I don't think it'll be hard to set up AWS Lambda and the Python script with AI-assisted code generation. I'm just real curious to learn myself then how to put the data into AWS database, time series database. Yeah, pretty cool. So like I'm using a data center out of Ohio, which is not too terribly far from where I'm living. Couple of them in the United States, couple of them in Asia. Canada has one. I'm probably closest to the Canadian one versus any of the United States one. Brazil has one. A couple in England too, or in Europe. Okay, so like just to drive this home is like we're here and we validated just now that we can publish a fake temperature sensor data through here, and then we're publishing this, and we got the data to what was it, Indiana, Ohio. So we sent the data to Ohio just to print it and validate it. Okay, so now the next big can of worms is like I have this running already. So let me just prove this to you. This is the handy dandy BACnet scan tool. We've been playing around with this. This is the I'm running this on here on the Windows machine. So like we're doing all of our work on a little Linux server right here. So right now, because most of the building automation technicians like myself, we're all familiar with these Windows-based tools like Yabe or whatever. So like this is the Boss Pi down here. It is actually this device PyTemp. So it has a temperature sensor wired to it, and then it's spitting out degrees Fahrenheit and degrees C. So right now, 78 degrees. I don't even know how accurate that is, but it could be about that. And then in degrees C, that is 26 degrees C. Okay, so like, I think yesterday, I think yesterday I talked a little bit about how this was wired to the Raspberry Pi. Let me just see if I can find that. Let me just do a quick scroll back to yesterday in my Google. Yeah, I think it was this one. So I'm just gonna put this tab back to here. So okay, so like on the Raspberry Pi, then we were wired to, this is the GPIO on a board. So the Raspberry Pi has all this GPIO, which you can use for doing electronics, which I don't know hardly anything about electronics. I know a little bit about AC and DC circuits from being a controls technician. I was really good at relay logic and AC and DC circuits for control circuits. But once you get into the electronics of a board, I just haven't studied that much. So basically, what I was trying to do yesterday, it was use this, this is common in BAS contracting, is like we would do thermistors and RTD resistance-based temperature sensors. So this is something from my old job. It's a 1,000 ohm RTD temperature sensor, a duct probe sensor. That's pretty common in HVAC systems. So what I wanted to try and do yesterday is like, can you wire this to a Raspberry Pi directly? And no, I found that out the hard way. It's like I needed some, maybe I'll do this in the future. It's like I need some little extra board that it's like a rectifier amplifier thing that can convert the resistance into electrical resistance in ohms to whatever to get the data into some kind of like a programming environment. So I need to figure that out still. More to come. But what I did have laying around is from some old Raspberry Pi kits I bought. I have a few of these like beginner Raspberry Pi kits. I've had this for a couple of years. I've never used it. So this is, they call it a one wire. Why it's a one wire makes no sense because it has 3 wires on the inside, but apparently it's a digital temperature sensor and it's waterproof. So this can get wired directly to the Raspberry Pi. It's like this actually. So what? Oh no, this is different. I need one of these where I can have this like. Let me show you how I'm wired it. But if you just notice this is like a resistor. The power in the blue was for common. Okay, so I think I'm wired into 3.3 volts, ground, and then this is the signal, the yellow wire. So I'm just gonna pan my camera here. Okay, pull my camera down. Okay, so this guy here, that's the Linux server. That's running Codex. It's also pushing the VibeCode app to GitHub. Sorry, like trying to pan my camera. So this is, it's basically, and then it's also going to run Ansible, and then push code to the BACpy, which is here. So this is the BACpy, and then this, if you can see this, this is it. This is how I have the breadboard with the resistor here, and then this is the red, the signal, the common, and then this is actually the temperature sensor right here. So this is the device all wired to a breadboard, and then in the long run, we're going to see if we can get this data to AWS. So yeah, pretty cool. I was almost kind of curious to do some kind of a test. So if you see this right now, this is the BACnet data, and I'm just going to do degrees Fahrenheit, still 70. I'll show you the code here in a second. But just to prove this, I haven't done this yet. I might pull out this. I'll pull out this jumper here for the I think it's a hot, and then do a refresh. Ooh, and it goes to 185. Interesting. So let's put the little hot wire back into it. It's just like little low voltage circuits. Come on, update. I think I put in the right one. Oh, there it goes, back to 79. Okay, so not too much different than what I would do at, this is all the cars. Lots of cars out there. So lots of buzzing cars. So like that's what I would do when people commission control systems, and point-to-point commissioning is like you would pull the wire apart and you would validate that this sensor is wired to the correct controller. So very common in controls contracting. So how is it doing this? I'm just going to close out of that. Well, maybe, I suppose we could just jump right into the Python BACnet Stacks playground. Okay, vibe code app 12. We talked about Ansible a little bit, so we'll use Ansible to push the code to the Raspberry Pi. Okay, so this is I had to, if anyone wants to try this, just go to Discord and start chatting. So AI created this code basically that reads the data from the GPIO. I had to cursor told me to run a few commands in Linux, which enabled the GPIO. And then also, this is a little bit of Python code that's sampling the data from the electronics. And then we basically just return that text, that value, as a temperature sensor value. This is our BACnet application. So BACpypes3, if you remember correctly, we have been going to BACpypes3 repo. So I'm just going to go to GitHub BACpypes3 into the samples. And then this is our mini device. So this is just on BACpypes3. This is a BACnet server. So we played around this a long time ago in this video series. Is how to make a discoverable BACnet device in fake data. So we're just using this again. But I'm only now adjusting it so that it has a degree C of the same temperature sensor I just showed you and a degrees F version. And then we're reading the real data from the GPIO of the Pi. So before when we originally tested this, we were just calculating fake values in Python, which is kind of like what we're doing when we're testing out the MQTT testing. We're just generating fake data, and then what I want to do is marry this all together. So like we'll have a BACnet API for local building, which is common in building automation. Then also we can be sending that data, same data, to AWS IoT Core. Okay, so probably enough of this. I just wanted to say, like, this little code base we're using to read the temperature sensor data from the Raspberry Pi GPIO, it comes from the same thing we've been talking about before in BACnet servers. This is the same code base that we used prior in this video series of scraping Open Weather Map API and then making a discoverable web weather BACnet device. Reference to old videos, or let me know on Discord if you want to know where that is. Okay, so let's see this code. This is electronics, the file we just looked at. This is actually the name of that sensor I showed you from Adafruit, a DS18B20 sensor, the one wire, even though that's 3 wires, digital temperature sensor. So the little bit of Python code that samples the electronics. And then this is the BACnet application that dumps everything into an analog value. A little function that goes from degree C to F. Okay, so then this is what we just saw before. This is how to make a BACnet degrees F point. This is how to make a BACnet degrees C point, analog values. And then we're just, that's our object name. So like when we fire up the tool again, if I go back into here, you'll see these names. So back into the PyTemp BACnet device, probably hard to see, but it's same name. This is the name, local DS118B temperature sensor degrees F. Here's the degree C version. That's these guys right here. Sampling electronics real time, 79 degrees. Okay, so the next big can of worms is how to get this onto AWS. So this is interesting. It's doing, we talked about this before, that BACpypes is all asynchronous Python programming. So it's actually doing an async IO to thread, because this looks like a synchronous task. So when you mash asynchronous and synchronous code bases together, there has to be done on a thread. And then this is how we update that. We update the present value. Okay, so pretty cool. So it's like 170 lines of code. So this should be just, I'm gonna ask Cursor to just make this into a test, like just a local BACnet test. And then we're gonna try and get this onto here. Okay, mix and mash. So there's a lot going on here. So basically, we're gonna ask Cursor IDE. Ansible is our tool, is our IT automation tool to update the Python code that'll be running on here. That'll sample the data, and then this guy is also, and then this guy will be spinning up the two BACnet points that we saw on here. So we already have that covered, like we are, just to really drive this home. I think this stuff is really fun. Like when I used to play around with this on construction sites and like, wow, I just made a discoverable BACnet device. That was like so cool. I thought, you know, you had to work for a manufacturer and have like a master's degree in computer engineering to do this stuff that you don't, you know, is the cool thing. Might be easier if you do, but okay, so like, okay, so just to drive this home, like this is the BOSS Pi right here. So we have this part working already, that we can see our one wire sensor right here wired to the GPIO, and we have BACnet data coming in, and then we tested it already that if you pull the wire apart like you do in building automation commissioning, that it goes to a value of 185, which is interesting. I did not know that. It seems to me in my Schneider Electric and Johnson Controls, when I used to pull the wires apart commissioning, it would go to like minus 277.7 or something, some weird number like that. So okay, so like the next thing we need to do, we're gonna see if we can do this now, is ask Cursor to make another Python script that basically marries these two together. So the ultimate goal is like we'll still have working BACnet scanning scripts, and then we'll also be able to see this on AWS. So instead of this guy sending the data to AWS, this guy will, the BOSS Pi will do all of it in one Python script. Okay, so let's vibe code this. Fun. Okay, so like, I'm gonna just drag this into the chat. Whoops, where'd it go? Try number 2, pull that into the chat. So that's our public fake temperature data to AWS through MQTT secure. And then, okay, so I'm gonna ask it, so say this works, and local BACnet testing, this works as well, yay. I'm going to tell it now what I need with Ansible is a feature to push to the Pi a new Python script that marries all these together. So we will read real GPIO, push, let's see. So we will read the real GPIO sensor data of the, I was going to find find this easier, I'll just drag it over again. Of that sensor, update the BACnet server points, which is working, but then the boss Pi on a new script will also just send the data to AWS IoT Core. Both need to work. And let's use Ansible to set it up. Okay, so I'm just gonna say like this could probably just be a test script or just enhance it for BACnet only, and in arg or something could publish the data to AWS. Please make sure the Ansible playbook, which we'll talk about, sends over all key and PIM security files as well. Let me know which Ansible commands to run. Okay, so what we need to do is, so basically it's going to, with an Ansible playbook, it's basically going to send over all of this stuff for the key and PEM files for MQTT secure, and then a new Python script. And yeah, this is really neat. One thing that's kind of cool with Ansible, so Ansible is an IT automation tool. So I think it's mostly common. I know people use it in IoT. So let's pretend that like this was running in hundreds of buildings and you have to push an update to all of your Raspberry Pis. So like what you would do is like this would be in some production environment, you would have like tail scale VPN or something to SSH into all of your Raspberry Pis. And then this will just be across the wide open internet via MQTT secure. So what is neat about Ansible is like we could be updating endless numbers of Raspberry Pis all at the same time. So that's the power of Ansible. It's something that I've been meaning to learn a little bit about. It's how to like basically if anyone that's familiar with Niagara building automation systems, and you have like a server, Niagara 4 server in connected to 100 JASes in many different buildings, like you can use features on the server to time sync all the JASes to do all these different tasks or something like that all at once, pull trends, data, alarms, automatic backup recoveries. You know, they can all be automated and kind of batched all at once and efficiently. So to kind of think of Ansible as an IT IoT automation tool. We're just using it for one device, but I think it's a good tool to at least like, I'm learning it, and then just to have that in like your memory bank that like, oh, I've heard that word before. Okay, so it built, we'll talk about this a little bit later, but okay, so it's asking us to change directory into here. So we'll change directory. Looks like I made a couple scripts. Excuse me, guys, sorry. Looks like it just copied some of this. Okay, so like what it makes is like a playbook, which is nothing more than like a file to send over, and then these different tasks. So long story short is like AI is really good at making Ansible playbooks. We should talk about this more in the future too. And it's like a Python library as well. Okay, so let's give it a try. If you use the local Ansible, okay, so okay, so this is the way I could do it myself. Okay, so the only thing that is confusing about this, I'm just going to say, I don't know which Ansible command. I want to say also the Ansible command needs to have a way to -- verify as well. Okay, so maybe just one more command here. Another thing we have to specify is how often it's sending data. I didn't even think about that. So, how often is the MQTT data published? Turning into kind of a long video, so thanks for playing. Thanks for every 2 seconds. Wow. Alright, what the heck? It's just for test purposes. Okay, so first time. Okay, so this is our command. Let's see if it works. Change directory. It's going to do some kind of bash script and then a deploy. 2 bash scripts, and I have to give my boss Pi SSH access. Okay, so right now it's should be sending the Python scripts to the boss Pi. So just pretend that this could be hundreds of Raspberry Pis running in real buildings, and then we could be pushing this through a MQTT pipeline or something, or I mean a VPN. The cool thing about this is with AWS IoT Core is like it gives you the security .key and PEM files and all that good stuff, and you can just be doing MQTT secure right across the internet without any VPN or anything. I think that's really cool. My experience so far with AI writing these Ansible playbooks are really good too. So it's setting up the systemd. That is something in Linux to keep a process running long term. So if the Raspberry Pi dies, or it's power blip in the building, and then the hard reset or something like that, systemd in Linux will will restart all the Python scripts, and then your BACnet application will start up again. Wow. Okay, so it's going. Got a bunch of stuff here. Okay, it looks like we're ready. Let's go check in BACnet, see if our BACnet API is. Sometimes what can happen is our BACnet API can go bad, and all of a sudden our BACnet goes down. Okay, so we still have a couple 80 degrees. Does feel a little warm in my office. Okay, so then we should be able to, in theory, jump to here. Oh, there it goes. Wow, this would be the 80 degrees. Wow, okay, so this is really cool. So this is the real data getting sent to AWS every 2 seconds, which is ridiculous. Yeah, if you see it updating. Wonder if I could even like warm up this even more. Warm up my little sensor. Oop, it's warming up. See right here, now we're getting to 82. Maybe the next time I'll get a glass of ice water and just to prove that it's doing something. Okay, so I think I should end it from here. This is really cool. I'm really happy that we got this far. The next thing I think we should do is, glance at the code base, what it made. Maybe we'll just do that on the next one, just because there's a lot that went on to this video. Next video, we'll study, we'll look at the Python code that's doing publishing MQTT data, MQTT secure across the internet from Upper Midwest to AWS IoT data center in Ohio, I guess. And the next process we'd be doing is an AWS Lambda handler, and then putting this in some kind of a database or something like that. So pretty cool. Yeah, so we'll look at the code base and then keep an eye on our Vibe App 11, which is the that is just the scripts of AI, just building the billing automation system. And who knows, maybe it could the point of this whole entire repo is that they could be a mix and mash of any of this stuff. Could be, like we could be doing Vibe App 11, but in the same format make something for AWS IoT. So like we're just making a massive model context. Maybe we'll do this too before I push the code. Sorry, this video is kind of long, but so the computer science theory stuff, which I've been really dawdling and I might get rid of this. So this was something that was I was playing around in some game development with generating random mazes. I might actually just retrofit this for Guideline 36. So this is something I have working in this other project, the Vibe Code Addict. In Java, I have this written. This is Guideline 36. This is probably I should do this as a whole dedicated YouTube video, but I might put some lessons in there for how to manually code Guideline 36 to do VAV box count, trim respond, and also the area handling unit. I also have a central plant validated in the field for this too. But basically, we could do this in Python too. It's not very complicated. It's actually, from a mechanical standpoint, it can be sort of advanced, I guess, but these are just really easy computer science algorithms. So we could, I'm going to ask AI to convert, this is Java code, into Python lessons. And it's really basic stuff of just counting up and down for God to make guideline 36 work. So we'll let's wow, that's a loud car. Apologize for that. Okay, so like I'm just gonna go into here and let's just vibe code this now. And then this is way beyond enough for one day. So okay, so the computer science theory lessons, which I'm really slacking on. Let's see, so we're on day 41, 43. Okay, so I'm gonna say, can you mod these days? Can you mod these days retrofit instead of random maze? We just need lessons for GL36. Each day could be for a VAV box, an AHU, and then central plant. Please add more days if necessary. Please go off of this working Java version, but make lessons in Python in the same format. Okay, so those are the days. Mod these days. So I'm just gonna, this is the raw text version. I'm just gonna copy all of this right into for this, paste. That's probably 3,000 lines of text in there. Then I also want to make it do, man, is that annoying outside. Sorry about that, guys. If you hear a lot of noise, that's not from me, it's just my busy location here. And then I just need to ask it to like, and lastly, update the README for those modified days. Okay, I'm gonna hit the enter. Then cursor can go nuts on modifying some lessons for computer science theory. We can save those for rainy days if we need something to do. Okay, so this is a really long video, and we'll kind of just probably recap tomorrow on where we're at, and then hope you're liking this stuff so far. I still need to figure out is like once I'm on AWS IoT is how do you put the data in the database? So it's getting into a little bit of cloud computing IT skill sets. And then once we have data in a database, we should be able to spin up like a Grafana chart or something, or hopefully there's some cheap, easy, and free way to just demonstrate this. I'd also like to throw it out there is like, I'm also looking for some freelance work right now. So like, I'm kind of in between some employers right now. So if anyone wants any assistance with this, getting set up, I do have like just an hourly free rate. If you want to develop something professionally, I can help you. Anything at all. So I'm kind of just have some very generic, pretty reasonably hourly free rates. I think it's even cheaper as hiring a building automation technician these days. So feel free to reach out. I love to do this stuff. All right, until then, have a good one, guys. Talk to you later.